A brief history of almost everything quantum. Pre-quantum era, the 1600s, very early 1900s. The early history of quantum physics was guided by the explanations of quantum phenomena through the eyes of classical mechanics, atomic structure explanations, and electromagnetism. Key contributions were made by Newton, Huygens, Young, Maxwell, among others. Through the very early period, developments in the field were marked by the two theories of light, Newton's corpuscular theory and Huygens' wave theory. 1672. Newton presents the corpuscular theory of light, which treats light as made up of particles. 1678. Huygens challenges Newton by presenting his wave theory of light. 1801. Thomas Young performs the double-slit experiment, establishes light to act as a wave, hence disproving the Newtonian corpuscular theory. 1807. Etienne Louis Malus discovers the polarization of light. 1815. David Brewster mathematically describes the polarization of light. 1819. Fresnel-Arago laws of polarization interference are published in Fresnel's memoirs. 1821. Fresnel introduces the concept of a black body. The discovery of electromagnetism by Ørsted started a chain of experiments into electrodynamics which eventually led to Maxwell's discovery. 1821. Hans Christian Ørsted discovers the existence of electromagnetism, confirming a direct relationship between electricity and magnetism. 1823. Ampere refines Ørsted's findings and introduces Ampere's law. 1860. Gustav Kirchhoff coins the term black body radiation. 1865. Maxwell introduces his theory on electrodynamics, thereby establishing light as an electromagnetic wave. He describes the medium of traveling of light as the luminiferous ether. 1887. A. Michelson and Edward W. Morley failed to test the luminiferous ether in their famous Michelson-Morley experiment, thereby establishing the absence of any medium of propagation of light. 1890–1906, Hendrik Lorentz develops Lorentz ether theory. In the late 1800s, physicists were marveled at the physics of the atom. The focus of the worldwide science community shifted to discovering what is inside the atom. In this period, the concepts of subatomic particles, atomic structures, and radioactivity came to light. 1887, Heinrich Hertz discovers the photoelectric effect while working with radio waves. 1895, Wilhelm Röntgen accidentally discovers X-rays. 1896, Henry Becquerel discovers radioactivity in uranium. 1896, Peter Zeeman discovers the now called Zeeman effect, i.e. the existence of spectral lines under the influence of a magnetic field. 1897, J. Thomson discovers the electron. Based on his discovery, presents his plum pudding model of the atom. The introduction of quantum mechanics, early 1900s, mid-1900s, with the incoming of the 19th century, began the rise of a new field of physics called quantum mechanics. Previously unsolved physical questions dating back to Newton came to be solved by this new theory. All of this began with Max Planck's explanation of black body radiation, the theory which he referred to as the quantum theory. Today, Max Planck is remembered as the father of quantum mechanics. This period saw the rise of some of the most well-known physicists ever, including Albert Einstein, though he opposed quantum mechanics due to its probabilistic behavior, Max Planck, Niels Bohr, Erwin Schrödinger, Paul Dirac, Werner Heisenberg amongst others. 1900, Max Planck introduces Planck radiation law to explain the emission radiations of a black body. He also postulates the quantization of photons with the now famous equation, A = h nu. Hence the field of quantum mechanics is born. 1902, Hendrik Lorentz explains Zeeman effect through his Lorentz ether theory. 1905, Albert Einstein explains the photoelectric effect, in which he treats light as particles, hence advocating Newton's corpuscular theory. He also introduces the world to the theory of special relativity. 1909, Ernst Rutherford performs the alpha-ray scattering experiment, also known as the gold foil experiment, introducing the concept of the atomic nucleus. 1909, Geoffrey Taylor demonstrates the formation of a single photon interference pattern, thereby reigniting the more than 2-century-old Newton-Huygens debate. 1913, Johannes Stark discovers the Stark effect, i.e. the electric field phenomena analogous to Zeeman effect, 1913, Niels Bohr introduces his atomic model and theorizes the quantization of atomic radius. 1915, Einstein introduces the general theory of relativity and Einstein field equations. 1916, Einstein theorizes the existence of particle-like momentum in Planck's energy quanta. 1916, Arnold Sommerfeld introduces the concept of atomic subshells and hence extends Bohr's theory of the atom. 1918, Ernst Rutherford discovers and coins the term protons in the atom. 1921, Theodore Kaluza publishes Kaluza theory after the preceding discoveries in a sudden boom in scientific discoveries spearheaded by the quanta and relativity. It became clear that a new field of physics, quantum mechanics, be formalized. Bohr, Heisenberg, Schrödinger started developing this formalization from the 1920s, which was soon joined by the likes of Max Born, Paul Dirac, and John von Neumann. 1922, Arthur Compton discovers the Compton effect. 1922, Otto Stern and Walther Gerlach perform the Stern-Gerlach experiment, hereby demonstrating the quantization of spin. 1923, Louis de Broglie hypothesis wave-particle duality, hereby postulating the Broglie wavelengths, lambda equals h.m.v. 1924, Wolfgang Pauli explains the fine structure of spectral lines using the concept of an internal angular momentum of the electrons. 1925, George Uhlenbeck and Samuel Goudsmit postulate the existence of electron spin. 1925, Heisenberg, Born, and Pascual Jordan develop the matrix mechanics formulation of quantum physics. 1925, Frederick Hund theorizes the concept of maximum multiplicity in an atom, now known as Hund's rule. 1926, Erwin Schrödinger develops the Schrödinger wave equation, the most important equation of quantum mechanics. 1926, Oscar Klein interprets Kaluza's hypothesis by integrating quantum mechanics, developed recently by Heisenberg and Schrödinger, one of the first ideas about quantum gravity. 1927, Werner Heisenberg publishes the article introducing Heisenberg uncertainty principle. Delta P delta x is greater than or equal to h 4 pi. 1927, Solvay Conference, Copenhagen interpretation of quantum mechanics is developed. 1928, Paul Dirac establishes the Dirac equations of quantum mechanics. 1929, Oscar Klein predicts the Klein paradox, i.e. quantum tunneling effect. 1930, Paul Dirac hypothesizes the positron. 1930, Paul Dirac theorizes the whole theory, also called the Dirac-C model. 1932, John von Neumann describes the mathematical foundations of quantum mechanics in terms of Hermitian operators and linear algebra. The rise of quantum mechanics mid-1900s, late 1900s, with the basic groundwork and mathematics of quantum mechanics already established, physicists now sought to complete the erstwhile incomplete picture of the atom, and in this process, discovered new particles. Hence, started the quest for particle physics, started all the way back by J.J. Thomson. And with the fears of another world war looming over the world, the physical research into the atom paved way for the development of arms of mass destruction, nuclear warfare. Key physicists included Richard Feynman. 1932, James Chadwick discovers the neutron in the atom. 1932, Carl D. Anderson discovers the positron. 1935, Einstein, Boris Podolsky, and Nathan Rosen publish the groundbreaking EPR paradox paper in which they challenge the completeness of quantum mechanics, supporting a hidden variable theory. 1935, Schrödinger develops his famous Schrödinger's cat thought experiment showing the implications of quantum superposition. 1936, Carl Anderson discovers the muon. 1939, Otto Hahn and Fritz Strassmann discover nuclear fission of uranium. Under the shadow of World War II, Robert Oppenheimer and others lead Project Manhattan. The focus of the world shifted from science to weaponry, and the period saw the invention of atomic bombs, hydrogen bombs, and other thermonuclear weaponry. Meanwhile, many different interpretations of quantum mechanics started developing, and the emerging field of particle physics caught the attention of physicists. At the same time, works continued in the field of quantum field theory, and the concept of a quantum computer was first theorized. 1940–1945, Oppenheimer discovers quantum tunneling. 1945, John Archibald Wheeler and Richard Feynman develop the Wheeler-Feynman absorber theory. 1948, Tomonaga and Schwinger theorize renormalization in an approach to quantum field theory. 1948, Richard Feynman introduces the path integral formulation of quantum mechanics and introduces the concept of Feynman diagrams. 1949, Freeman Dyson invents the Dyson series. 1952, David Bohm builds upon Louis de Broglie's discontinued work to propose the Bohm interpretation of quantum mechanics, also called the hidden variable theory and pilot wave theory. 1952, Wolfgang Pauli, not to be confused with Wolfgang Pauli, invents the ion trap, later used in trapped ion quantum computing. 1956, Chen Xiongwu carries out the Wu experiment demonstrating parity violation in the weak interaction. 1957, Hugh Everett formulates the many worlds interpretation of quantum mechanics. 1961, Klaus Johnson performs the double-slit experiment with electrons and establishes the wave-particle duality is a fundamental property of quantum mechanics. 1963, Eugene Wigner lays down the foundations for the development of symmetries in quantum mechanics. 1964, John Stuart Bell introduces the Bell's inequality, also called Bell's theorem, to disprove hidden variable theories in quantum mechanics and solve the EPR paradox. 1971, Martinez, J. G. Weltman and Gerardus, T. Hooft predict the existence of the gluon. 1982, Richard Feynman introduces the idea of a quantum computer in his paper, Simulating Physics with Computers. Quantum applications late 1900s present day, with Feynman's idea of simulating quantum phenomena on quantum hardware, the race for building quantum applications became faster. The period was accompanied by the invention of new quantum protocols, hardware implementations, and quantum algorithms. At the same time, new theories called superstring theory and M-theory came into existence in the field of theoretical physics. 1984, Charles H. Bennett and Gilles Broussard invent the BB84QKD protocol. 1989, Joseph Polchinski discovers D-branes, a major addition to string theory. 1992, David Deutsch and Richard Georgia invent the Deutsch-Georgia quantum algorithm demonstrating the first quantum speedup. 1994, Peter Shaw invents the Shah's algorithm, which has the potential to break modern-day RSA cryptography. 1995, Edward Witten gives birth to M-theory, revisiting an abandoned theory called string theory. 1996, Love Grover invents the Grover search algorithm for efficient database search. 1997, quantum teleportation is experimentally realized by two research groups, led by Sindhu Popescu and Anton Zeilinger. 1998, Isaac Chang, Neil Gershenfeld, and Mark Kubanek create the first quantum computer 2-qubit that could take an input and output a solution. The race for building quantum computers began, spearheaded by tech giants like Google and IBM and accompanied by new startups like Rigetti and D-Wave. More emphasis came to be laid on the applications of quantum phenomena. At the same time, new lines of physics developed seeking to merge quantum mechanics with gravity into quantum gravity, seeking varied approaches to quantum mechanics, and string theories. 1999, Yasunobu Nakamura and co-workers at NIC, Japan, demonstrate the first superconducting qubit. 2000, David P. DiVincenzo outlines the DiVincenzo criteria for the creation of quantum bits or qubits. 2012, Large Hadron Collider at CERN experimentally proves the existence of Higgs boson, colloquially called the God particle. 2014, scientists transfer data by quantum teleportation over a distance of 10 feet with 0% error rate. 2016, IBM launches cloud-based platform IBM Quantum Experience. 2019, Google claims quantum supremacy with its Sycamore quantum processor. 2020, Google AI simulates Hartree fork on a superconducting quantum computer, illustrating quantum advantage for chemistry problems. 2021, Fermilab experimentally observes the anomalous magnetic moment of a muon. With this, we finish our timeline of quantum developments yet. But, as told, this is a dynamic list, getting updated from time to time, as more developments come into existence and our knowledge of the smallest scale of the universe widens. Thank you for watching.